Section 6.4, Rectangles, Rhombuses, and Squares. By the end of this lesson, you should be able to use properties of rectangles, rhombuses, and squares. Oh my. Well, what is a rhombus, rectangle, or square? Well, taking a look at the definitions, we know that a rhombus is a parallelogram that is equilateral. So it has the same properties that a parallelogram does, but in addition to that, you're going to find that all of its sides are congruent. A rectangle is going to be a parallelogram that's equiangular. So it's going to have all the same properties of a parallelogram, but it's also going to be equiangular. And a square is a parallelogram that's both equiangular and equilateral, or we can call that regular. So it'll have all the same properties of a parallelogram, but it's going to be equiangular and equilateral. We can use these properties to solve for measures. So in this diagram, we're given that EFGH is a rectangle, and we need to solve for y. Well, taking a look at this, I know that a rectangle needs to be equiangular, and the only way that that'll happen is if all of its angles are equal to 90 degrees. So we can set up an equation saying that 7y plus 6 is equal to 90 degrees, and we can use that to solve for y. So then we can say that 7y is equal to 84, and then y is equal to 12. Now, algebra involved isn't very difficult, but you need to make sure that you understand your properties so that you can set up the equations. Now, rectangles and rhombuses have a few more properties that we need to make sure that we keep in mind other than the definitions. So the first one we have is that a parallelogram is a rhombus if and only if its diagonals are perpendicular. So in addition to being a parallelogram with all sides congruent, we're going to notice that its diagonals are perpendicular. Parallelogram is a rhombus if and only if its diagonals bisect opposite angles. So it'll have all the same properties of a parallelogram, but we're also going to see that its diagonals are going to split its opposite angles into congruent pieces. In other words, it bisects it. And last but not least, we have one for a rectangle. And a parallelogram is a rectangle if and only if its diagonals are congruent. We can take all this information and organize it because you've received so many different facts and properties about quadrilaterals. So we'll make a quadrilateral family tree. And we know that a quadrilateral is a polygon with 4 sides. We also learned that a property of quadrilaterals are that the sum of their interior angles is 360 degrees. Next, we learned about parallelograms. And parallelograms, by definition, have both pairs of opposite sides that are parallel. And it's going to be a quadrilateral because it comes from the quadrilateral. And we have our following properties. Opposite angles are congruent, opposite sides are congruent, diagonals bisect each other, consecutive angles are supplementary. And then we also learned that if one pair of sides is parallel and congruent, we can say it's a parallelogram. But now we're going to see where our rectangle, rhombus, and square end up fitting in this family tree. They're all parallelograms, so we're going to have it coming from parallelograms. Rectangles, they are equiangular parallelograms. So in other words, all their angles are congruent. Now, a property of rectangles, a property of parallelograms that are rectangles are that they're going to have diagonals that are congruent. So we're going to list it under a property. Rhombuses, we found out, are equilateral parallelograms. And properties that rhombuses have are that diagonals are perpendicular and diagonals bisect opposite angles. Now, squares are both equiangular and they're both equilateral. So you can kind of consider them to be the baby of a rectangle and a rhombus. And so even though all that we say is that it's a regular parallelogram, it's going to have all of the characteristics of everything else that came before it. Same thing with a rectangle. A rectangle will have all of the characteristics of a parallelogram and a quadrilateral. And this chart is going to be very important for you to make sure that you have as an organizational tool. So I recommend that if you haven't already, you maybe pause and copy this down because it's going to help us with our next few examples. So for these next few examples, we're going to decide whether each statement is true or false, and we need to explain our reasoning. The first statement is the diagonals of a rectangle sometimes bisect opposite angles. And this chart we're going to refer to. So the diagonals of a rectangle sometimes bisect opposite angles. Well, bringing these back, we see that diagonals are congruent in a rectangle, but diagonals that bisect opposite angles is a property of a rhombus. Well, a rectangle can sometimes be a rhombus when it's a square, because a square is both a rectangle and a rhombus. So we can consider it to happen sometimes. So looking back at our statement, it says sometimes bisect opposite angles. And this is true, so we'll go ahead and mark this as true. And we can say this is true when a rectangle is a square. Bringing this further down, our next one says the diagonals of rhombus are always congruent. So once again, let's take a look at our chart that we have here, and we'll bring back all of our properties. Well, the diagonals of a rectangle are congruent, but the diagonals of a rhombus bisect opposite angles and are perpendicular. But we can say that it'll sometimes have diagonals that are congruent when it's a square, but this isn't happening all the time. So our question or our statement that said the diagonals of a rhombus are congruent is only sometimes true, and our statement wanted us to say that it was always true. So we're going to have to say that this is false. And it's false because that is not a property of rhombuses. And our last statement says the diagonals of a square are never perpendicular. So once again, let's look back at our chart, and the diagonals of a square, well, there's nothing here that's listed, but we know that a square is going to have all the same properties of everything that came before it. And so it's going to have all the same properties of a rectangle and a rhombus. So yes, it's going to have diagonals that are perpendicular, and that's going to always happen. So looking at our statement, we're going to have to say that this is false, because really the diagonals of a square are always going to be perpendicular. Now, that's a lot of information. We're going to have a lot of time to practice this tomorrow, because as you can see, just a few quick examples isn't going to explain everything. But that really concludes the main information that we have from this lesson, so it's time for our joke. And our joke for today is, what do you give a reindeer with an upset tummy? Well, you give him an Alka-Seltzer, of course.